everyone. I'm Nathan McBride, working at McBride. Thanks for coming along today, and yeah, pleasure to be here. Thanks for organising it and everything. I wrongly sent the wrong title when, so I think it was titled "The Transition into PHP, Modern PHP," but it's more about solid development. And I will go over Magento briefly, but it's more PHP related because Magento have done a very good job at decoupling from a framework, and they've built a nice modular framework. So yeah, the talk will be sort of around the 5 solid principles in software engineering. Could I get a show of hands for how many people know about the solid principles already? That's pointless doing stuff then. But yeah, so you guys are going to have to bear with me a bit while I explain it to those that don't know.
Just give me
No worries.
That's the one.
So hopefully I'll press the right button now. So yeah, who am I? I'm Nathan McBride, as I said, work at McBride. Magento 2 blogger, very active in the community. There's my Twitter handle. If anybody wants to tweet any abuse at me, please do. Just refrain from shouting, so I may have a panic attack. And there's my blog if anybody's interested at all. So what's Solid? Solid is an acronym coined by Robert Martin. Each letter in Solid stands for a software engineering principle. So S, single responsibility, O, open closed, L, LISKOV-SUBSITUTION, I, interface segregation, D, dependency inversion. I'll go into what each one of these means briefly now. So S, single responsibility, a class should only have one reason to change, or it should only have one purpose. So I've got several bad analogies going through this, so you have to bear with me. So my analogy for this one is you wouldn't have a sales team member packing orders in a warehouse. It'd be the same for a class. You don't want it doing multiple things and have it multiple reasons to change. So here's a bad implementation. If I've got a module or a class or whatever placing called customer, and it's placing an order of member of customer service, the member of customer service taking the order, saving the order, dispatching the product, and then adding the sales to the sales report, the order to the sales report, sorry, then you can see like this class or person has too much responsibility. So for instance, if this was a class and your boss asked you to change how to add the sales an order to the sales report, and you cocked up the code and deployed it, it's going to break how the customer service takes the order. So I'm sure we've all been in a situation where you change a bit of code here, it breaks over here. That'd be why, because you've written a bad implementation with tightly coupled code. So here's a slightly better implementation. You'd abstract each sort of method into its own class. So your customer would place an order with a member of customer service who takes the order, and then he passes it to the administrator, or this would be a persistence layer in this role, or the database. And then the warehouse or the accountant would communicate with the persistence layer to get the order. The warehouse would dispatch the order, and then the accountant would add the order to the sales report. So you can see now if you did change the code in the accountant class, sorry, this is a bit of a weird analogy, so again, but if you did change the order in the accountant class, how it's added to the reports, then it's not going to break how the member of customer service takes the order anymore. This isn't a perfect implementation, it's still pretty tightly coupled, but I'll come back to it, how you can improve it. So open and close, classes should be open for extension but closed for modification. Is anyone familiar with Magento here, or are we the only Magento devs from McBride? Cool, so do you know Ben Marks? He always says don't edit the core basically. So you shouldn't, so if you're writing code you want to write it in a nice extendable way where people can change the behaviour without having to edit the source code itself. Vice versa, if you need to change the behaviour of someone else's code, you shouldn't be editing the source code. You should use things like dependency injection and extension to modify the behaviour. So here's like the classic example of a badly written class. It's a class shape. It's got 3 protected variables, which are circle, square, and rectangle. These have some basic meta information about the shapes. Then I have a public function draw, which draws the shapes and accepts an array of an assumed shape. I have a switch statement in this class, and it switches the name. So in the case it's a circle, it performs some logic to draw a circle. In the case it's a square, it performs some logic to draw a square. In case it's a rectangle, you get the point, and then it has some default draw logic. So imagine you need to add a triangle to this class. It's going to be very easy, hard to extend, sorry. You're going to have to edit the source code and then edit the switch statement, which makes for bad maintainability. You'd be much better having a base class of, say, shape, and then you'd have your circle, extend shape, and then you'd override the draw method and perform some logic to draw a circle in there, or same with square and rectangle. So if you needed to add a triangle now, you would just extend your class shape and have override the public method draw. So yeah, and if you were to mess up the code in triangle, it's not going to break circle, square, rectangle, which is more important. LISKOV-SUBSITUTION's big ugly maths equation. Is there any mathematical people in? Cool, I won't give you time to read it then. So when extending the class, the new instance of your class should be substitutional anywhere in your application that the base class is used. So you shouldn't be changing things like parameters passed to the methods, the return types of class. So another bad analogy, imagine you've written a bit of software that passes, say, boxes of bar stools to a member of the warehouse team in some warehouse, and it's passing them small bar stools, and suddenly it passes them an unexpected object type of pallet. You're going to break that warehouse member, and or in code examples, you're going to break your application or break another person's module. Interface segregation. An interface should not force an implementation to integrate methods it doesn't require. So you wouldn't add responsibilities for the warehouse responsibilities, sorry, in a Salesforce member's contract. So imagine you did do that, and your boss has a copy of his contract. He doesn't know anything about the person, but he goes and asks him to dispatch an order. He doesn't know where the warehouse is. He doesn't know how to dispatch an order, and he's not going to be able to do that. So it's going to either break down your company, or the boss is going to more likely fire the member. And then sort of have a go at you for hiring him. So it's the same as in software engineering. If you're promising methods to an implementation and they don't exist, then they're going to use those methods and probably break your application. So here's an example of that. Imagine you have a vehicle interface that promises methods accelerate and check oil. A car could implement this interface no problem, because you can accelerate in a car and you can check the oil. But bicycle, you can only accelerate. I guess you can check the oil if you check the oil in the chain. If you want to be pedantic, but for this example, it wouldn't really work. So you'd be better off doing this, writing two interfaces. So you've got nice thin interfaces, and having car implement both these interfaces. Or you could have engine interface, extend vehicle interface, and then the car would implement that interface. Does everyone know what interfaces are? Sorry, yeah, cool. Dependency inversion. This isn't dependency injection. They do sort of go hand in hand. High-level modules should not depend on low-level modules. Both should depend on extractions. Extractions should not depend on details. Details should depend on extractions. So, Salesforce member in your company doesn't care about the way in which an order gets shipped by the warehouse, so he doesn't care that the box is picked from the racking, a label is printed, and then the label is put on the box and dispatched. He just wants the tracking code back from the warehouse. Or he doesn't even care if it's sent by a warehouse, for instance. It could be fulfilled by Amazon or something like that. So this is from my example earlier. A customer places an order with a member of customer service. What if your customer was quite antisocial and like I am, for instance, and he wanted to place an order through the web? You're forcing your customer to use this solid implementation of customer service to take the order. So to invert dependency, you'd have an interface that sits between the two, an order interface, and then your customer or your controller can decide which implementation your customer uses, whether it be the web checkout or customer checkout, because he knows that it will have that take order method on it. So why write solid code? It avoids code duplication, makes code's maintenance easier, improves readability, Helps you decouple from frameworks, which is the biggest thing. As Magento developers, we don't want to write Magento code anymore. We want to write like nice PHP libraries, contribute to the PHP community, and then specialize integrating those libraries into Magento, which avoids code rot because we can use all your guys' libraries as well. We can share libraries amongst us. Ultimately, you can write code you can be proud of. So this is probably my only Magento 2 slide, so I do apologise. There's a few things we've got in Magento. PHP unit, I imagine you're all familiar with that, so we can test our business logic and the return types to adhere to the LISKOV-SUBSITUTION rule. Composer, just basic package manager, so it makes single responsibility on high-level modules a lot easier, and it makes switching out implementations easier. Dependency injection, factory methods, and interfaces all help to switch out implementations really easily, so we can easily adhere to the open-close rule in our code. PHPSW support, so we've got strict scalar hints, or Scala, I'm not sure how it's said, but this helps us adhere to the LISKOV-SUBSITUTION rule again. Magento is now a PHP Fig member, for those of you that are interested, so we now have a voice in the PHP world. We can get some rubbish interfaces towards you. Interceptors, or aspect-oriented programming. So there's a really good talk on YouTube by Daniel Sloop about aspect-oriented programming, if anyone wants to know more about it. I will go into it briefly now. So what AOP allows you to do is have a point cut at any public method in your application, either before, after, or around, and then you can modify behaviour without actually touching the source code itself. So yeah, require.js and jQuery rather than prototype.js now. This is front end, so I'll skip over that. Magento 2 is now on GitHub, so we can no reason to complain anymore. We can just change stuff. Here's an example of a badly written class. It doesn't adhere to the any solid principles at all. I'll briefly go over what this class is doing. We've got a class PHP Southwest that implements a talk interface. This talk interface promises the method getTalkTranscription. First of all, we query the database for transcription. This is in the method, sorry. And we pass the name to the public function query database for transcription, make a connection to MySQL, and then query talk transcript table and get the talk by talk name. And then we return the first item. We then take the transcription and pass it to a format class, and then we format the transcription into HTML and return it. This will probably pass most unit tests and integration tests. However, when you give it the Jim Carrey mutability test, definitely fails. So then, what's wrong with this class? This is breaking the first rule of LISKOV-SUBSITUTION. It's breaking the first rule of solid, which is single responsibility. So imagine the database structure changes, or you want to use a new database, you're going to have to edit the public method query database for transcription by name. And then if you wanted to change the formatting to be in JSON, for instance, you'd have to change this class. It has multiple reasons to change. This would be the same as a sales team member to place an order. They have to get a product from the warehouse. To do this, they go into the warehouse, they print a label, they pick an order, they package an order, and then they dispatch an order. Then they go back with the tracking code and then format and email manually to their customer and send it. You can see how inefficient this would be in a company. It's the same in your code. Or like if you're a startup, maybe you would have a sales team member doing all this, but then if a sales team member is going into the warehouse and picking a parcel, are they still a sales team member, or have they adopted a new role and are they now a warehouse member? So that's one way to think of it, I guess. So here's how I would improve the class. I've abstracted the logic into their own methods, into their own classes, sorry. So the logics remain the same, they're just abstracted in their own classes. So this means if I need to change how we connect to MySQL or the HTML formatter, we can do it in their own classes now, and it will break there rather than here. So yeah, Jim Code's slightly happy now. He's still pretty dull looking. So imagine we wanted to switch the implementation of MySQL out to Elasticsearch now. This would be very hard using this class. We'd have to make a new instance of MySQL and then override methods, which doesn't make much sense just to adhere to this implementation. Or same with HTML formatter. If we want to format in JSON, our JSON formatter is going to need to extend our HTML formatter, and that doesn't make much sense. So to improve this, I'd create two interfaces: a repository interface for getting the transcription by name, and then a format interface for formatting the transcription or formatting text. I've now created two formatters. The top one, you can't really see it on the slide, but it says HTML formatter, and then it extends, it implements, our format interface, and then we're forced to have the public function of output, it accepts text, and then I just use the inbuilt NL2BR function, which will return HTML. Then I have a JSON formatter, which implements the format interface, has the output method, but it just returns JSON encoded text. Now I can add the interfaces in the construct of this class, and so this class no longer cares whether it's being passed a HTML formatter or a JSON formatter. It just cares it has access to the format method, which it still can use. Jim Kerr is slightly happier, but he's still a long way to go to get him to his normal self. So what's wrong with this now? We could still easily break LISKOV-SUBSITUTION rule. So imagine if you're getting talk transcription, you're probably going to echo that straight away in some view file. So if you suddenly pass it in an array, you're going to break your application. The same is if in the warehouse you suddenly pass someone used to being passed bar stools, pallets, they're going to break. So to help us adhere to LISKOV-SUBSITUTION, we can add scalar hints, type hints, return types in our interfaces. We promise that any parameter will be passed to get a transcription by name will be a string, and then the return type will be a string. I'm assuming everyone's familiar with PHP7. And then the same with the format interface. This forces out my implementation to use these, adhere to this contract. And then just to be extra secure, I've also done this in getTalkTranscription and the getTalkTranscription interface. I haven't showed you the interface in this because there's not much point, I don't think. So yeah, Jim Kerr is getting pretty happy now, but he's growing a bit old, so I think I'm boring him a bit, so I'll try and wrap up. With a unit test. So all this test is doing is asserting that getTalkTranscription will return a string, which we sort of already know because I promised it will, but this is just more mainly to show you how easy testing is when you're using single responsibility. So I create two mocks, a repository interface mock and a format interface mock, and then pass them into PHP Southwest because I don't really want to test HTML formatter in this class. I only want to test get transcription by name. I'm not sure if this would actually work because I don't think PHP unit supports scalar hints. I might be wrong, but yeah, I think that's everything. As mentioned earlier, MeanBeer hiring. So got a slide on that. I think I finished slightly early. Wouldn't be the first time. So if anybody's got any questions or anything, please shoot.
If you strip down your classes so much, they're only doing one thing. Why do you need classes anymore? Why not just use functions?
Because you can't inject functions into other functions.
Yeah.
So and then I guess, and you can't use polymorphism, which is probably the main reason. I guess.
You could if you use invocable.
Possibly. Things would get messy though, wouldn't they?
Hilariously,
Yeah. Any more questions, or can I?
What happened to your leg?
So Tom said I wouldn't be able to get through this without answering my leg. I fell off a moped in Thailand, and they completely botched the surgery. I had 3 screws in my leg in Thailand, and they missed with all 3 screws because I broke my ankle. So I had to get it redone over here, and it keeps going wrong. Just like one of my implementations. Anything else? Can I hobble my red face over there?
Cool.
No?
Thanks very
Cool.
much.
Cheers.